Which functions have inverse functions? Which functions have inverse functions? All of them? No. No. So let's take a look. When we started chapter 2, we looked at 3 pairs of bubbles. Oops. So here they are again. The first one was something like this. Second one like that. And this was the third one. You can look back at those bubbles at the beginning of chapter 2. Okay. Is this a function? Yes. Now the question is, if I decide to go backwards, can I create a function? This x corresponds to only one y, this x corresponds to only one y, and this x corresponds to only one y. So this is a function with a very special property. The very special property is called one-to-one. One-to-one function. Meaning, to each y, it also corresponds only one x. Not just to each x, one y, but also to each y, one x. Only one-to-one functions have inverse functions. So I'm going to write that note in a minute. What about this function? Is this a function? Yes, it is. To each x only one y, each x only one y. But question is, when I want to go backwards, can I? Can I find a function going backwards? To this x, it corresponds to different y values. So this is a function, but it's not one-to-one. What about the third scenario? What can you say about the third scenario? It's not even a function. There is nothing to discuss. So here's our next note. Note, only one-to-one functions they all have inverses, but only one-to-one functions have inverse functions. Only one-to-one functions have inverse functions. Okay. Let's look at 3 graphs, and you will tell me what I graphed. The first graph. What did I graph here? From those 7 base functions. It is an absolute value of x. Is this function one-to-one? By the horizontal line test, for this y value, we read 2 different x values. For this y value, we will have 2 different x values. Is the absolute value a one-to-one function? No. No. Not one-to-one. Will it have an inverse function? No. What function is this? Linear. By the horizontal line test, for each y value, do I read more than one x value? No. Is the linear function always one-to-one? Yes. Perfect. What type of function is this? Square root. By the horizontal line test, is this a one-to-one function? One-to-one. So the vertical line test tells us whether the graph is a function, the graph of a function. But the horizontal line test says, well, is the function one-to-one? Okay. Now I would like you to give me a function that is a linear function, any linear function you can think of, so we can find its inverse because it's one-to-one. It will have an inverse function.
4x minus 2.
4x minus 2, awesome. Is this a linear function? Is it one-to-one? Good. There is a 4-step procedure for finding the inverse. First step. By the way, the notation F inverse, that's how we read it, is this. Do not get confused and think that this is 1 divided by F, because 2 to negative 1 is 1/2. That has nothing to do with this. I still care, Stephen. I still care. Okay. So, first step. We replace f of x with y. But now I want you to say, you allow me to or you don't. Am I allowed to? Yes, because f of x and y, they are the same thing. So this is y equals 4x minus 2. Awesome. Number 2. I'm going to write it and then I'm going to ask you again if I'm allowed to do this. Interchange x and y. Meaning, I see y, I put x. I see x, I replace by y. So now the question is, would you allow me to? And let's discuss this before you answer. So the function takes x to y. The inverse function will have to take this value back where it came from. What does this become for this function? So this is the y value for f. But what does it become for f inverse?
Domain.
It's x value, exactly. That's why I am allowed, never again, but this is the case in which I'm allowed to interchange x with y. Because the y value of function f becomes the x value for function f inverse. Perfect. So now in step 3, we have to solve for y. Solve for y. How do I solve this equation for y? I have to add 2 and divide by. So this is x plus 2 over 4. Do we agree with x plus 2 over 4? Acceptable? Okay. In step 4, I will use the notation f inverse of x to represent exactly what? That's it. And this is the inverse function of 4x minus 2. Now here's a question. What if you say to me, prove it? Prove it that it's correct. How will I prove it to you?
You graph it would be perpendicular.
No, I'll get to that in a minute. You're always ahead of me, which is awesome, but that's not the case. I'll show you in a minute. We're going to graph both in a minute. So you ask me, prove it. How will I prove to you that this is indeed the correct function inverse of the given 4x minus 2? What do I have to show to convince you? What do I have to calculate in order to convince you that this is indeed the function inverse and there is no other of 4x minus 2? And before you answer,
Substitute.
Exactly. All I have to do is calculate f comp f inverse. What should the answer be if our calculations are correct?
X.
Plain x. And then I will reverse and find f inverse comp f of x. What should the answer be if they are inverses of each other? Good. So let's just calculate one of them. Would you like f comp f inverse or f inverse comp f? Is this okay? Okay, so this is f of f inverse. which is f of x plus 2 over 4. I'm going to copy here f of x because it's on the previous page. And now please tell me what to write.
Four X minus 2.
So f of whatever is 4 times whatever minus 2. This is my whatever now.
Okay, so 4
Perfect.
times
Yes?
X plus 2 over 4
Excellent.
minus 2.
Excellent. Perfect. So now I will simplify 4 with 4. What is left from the product?
X plus 2.
Very good. And then I have to copy negative 2. These two will go away, and the answer is? Good. So now I hope we all vouch for this as being the inverse function of 4x minus 2, correct? Agreed? Okay. So now I'm going to copy those functions one more time here, because now I would like to graph them both on the same coordinate system. Graph both on the same coordinate system. Okay, so I have the first function, which is y equals 4x minus 2. When x is 0, how much is y? Perfect. And what is the ordered pair?
0.
Awesome. So now I want when y is 0. I will move 2. So I have 2 equals 4x. And I divide both sides by 4. And I get x equals 1/2. And what is the ordered pair now?
1/2 0.
Very good. So let's graph. I will graph 0, negative 2. And I will graph 1/2 0. I will connect and extend the line. I will write that this is f of x, which is 4x minus 2. Without looking anywhere, without calculating anything, I shouldn't say looking, but I should say calculate, without calculating anything, I would like to get from you 2 ordered pairs that will help us, that I have to plot, that will help us graph F inverse. And no Kyle and no Nate. Anyone else? Are there 2 ordered pairs that you would say, oh, plot this and this, and you're going to graph F inverse? So let's talk about this. So the first point is 0, negative 2 that we determined. The function applies to 0 and gets negative 2. Now the inverse function is applied to
2.
one more time.
2.
0. The function is applied to 0 and returns negative 2. The inverse function is applied to
-2.
and returns.
0.
Give me a point then for F inverse.
-1, 0.
I cannot make it up. One more time. If the function brings 0 to negative 2, the inverse function, remember, I'm giving you 5, but I'm taking it back.
When should do -2, 0?
Exactly. Exactly, that's all I wanted you to say. So now the function takes 1/2 to 0. What will the inverse function do?
0 to 1/2.
Exactly. So 0, comma 1/2 is this point. Before we graph and connect and do anything here, this is very important, we're going to write it as a note. Can anyone tell us what function I'm graphing right now? indeed y equals x. This is the first function we graphed out of those 7 in transformations. I'm sure you see that the function crosses y equals x at this point. Let's say it's not the case, but all points on this line have the same x and the same y. So let's say this is 1, 1. Reverse that and tell me what to plot. Well, let's say it's 2, 2. Reverse that and tell me what to plot. So the point I'm making is, if the function crosses the y equals x, the inverse function has to cross at the same point, because reversing the order of the coordinates there, it will not make any difference. And as you see, my graph is not going to be perfect. Except these 3 should be lined up, but they're not. Sorry about that. So this is f inverse of x, which we determined to be x plus 2 over 4. And here's our note. And see why I don't like writing on the board, right? So this and this should overlap. Maybe not, because my graph is far from being perfect. But this and this should overlap. And they don't, as you see. My graph is far from being perfect. But they should. Because at any point in time, and this is the note, the graphs of f of x and its inverse are always symmetric, WRT. The graphs of f and f inverse and its inverse are always symmetric with respect to what? The line, very good. The line y equals x. So the answer now I can answer, they are not perpendicular, but what you meant, I think, is this. If I connect these 2 points, the line that connects them, because they are symmetric, has to be perpendicular to y equals x. If I connect these 2 points, the line that connects them must be perpendicular because they are symmetric. If that's, I think that's what you meant. Very good. Any questions here? I would like to look at a word problem to see what do we really do with the inverse function. So let's look at 67 on page 323. Ready? We have a graph. They're showing us a graph. And before I even read the text, is this the graph of a one-to-one function? By the horizontal line test, 67, the graph I see in 67 is a one-to-one function. Let's see. The graph represents the probability of 2 people in the same room sharing a birthday as a function of the number of people in the room. So let's say we are 20 people now in the room. What are the chances that 2 of us share the same date and month? Okay, so if we're 20 people, what is the probability that 2 of us have the same birthday? Let's say 42%. If there are 60 people in the room, what is the probability that 2 of them happen to have the same birthday, day, and month? Almost 100%. Okay. Explain why f has an inverse that is a function. It's very clear. It's one-to-one. But now here's part B. This is an application, interesting application of inverse functions. Describe in practical terms the meaning of f inverse of 0.25. What does that mean? So now we are going backwards. So this is x and this is y, meaning 0.25 is here. So we should have how many people in the room to say or think or hope that the probability is 25% that 2 of them have the same birthday. how many people should we have in the room? Let's say 14, 15. That's what F inverse of 0.25 means. What about F inverse of 0.5? It means that if I want the probability to be 50%, there's no guarantee, but if I want the probability to be 50%, how many people should I have in the room? So that two people have 50% chances of being in the same room and having the same birthday date and month.
Is that 50% or 0.5%?
50% or 0.5% is the same thing. So 50% or 0.5. So about 22. And finally, F inverse of 0.7. So for the probability to be 0.7, we should have 30 people in the room. So that's a typical example of how the inverse function works. Any questions? Okay, so I'd like to look at on page 322 at problem 56 and problem 58. So we are asked to find G comp F of 0, and we're asked to find F inverse of G of 1. And we're given two tables. We're not given the functions. So they say negative 1, 1, 0, 4, 1, 5, 2, negative 1, negative 1, 0, 1, 1, 4, 2, 10, negative 1. That's all the information we have. And we're asked to find the G comp F of 0. What is the first thing I have to write here? G of F of 0. That's my starting point. I have to start with the inner function. How much is this?
4.
Do we all agree that F of 0 is 4? Agreed? Okay. So then this is G of, if this is 4, then this is G of 4. Good. So now let's look at G of 4. When X is 4, how much is G of 4? 2. Very good. So that's the answer. Now let's think about this one. Where is the starting point again? Yes, the inner function. Good. So this is F inverse of, I go to G, I look for 1. How much is G of 1? Perfect. But now remember what I'm looking for. So the function is applied to a number and returns 1. The inverse function is applied to 1 and returns that number. So what do I do? So I want to find F inverse of 1. But I know there must be a number that F brings to 1 that F inverse has to take back. What is that number?
1.
Yes, negative 1. So F is applied to negative 1 and gives us 1. So then F applied to 1 will return that particular number. So the answer would be, do you all agree with negative 1? Let's look at another. Let's say F inverse of G of 10. F inverse of G of 10. Where do I start? Yes, I start with 10 inside G. How much is this piece? Do you all agree with negative 1? So then we want to find F inverse of negative 1. So F inverse of, careful. I didn't even look. Careful. So function F somehow brings this negative 1 in the second set. because now I want to apply f inverse to it to get this number. What number do we apply f to get negative 1? 2. So this must be 2. F of 2 is negative 1. And f inverse of negative 1 must be?
2.
Is that clear? Should I repeat this?
Yeah, just once.
Very good. Yeah, let's do it one more time. So it's clear that g of 10 is negative 1. G of 10 is negative 1. Agreed? Okay. So now we want to find f inverse of negative 1. So I know that f is applied to a number. I don't know which number. F is applied to a number, and it gives us negative 1. Because now I want to apply the inverse function to negative 1 and get back to that number. So I have to look at f and see which x value creates f of x to be negative 1. So I look at negative 1, yes. So obviously 2, f of x is applied to 2 to get negative 1. Better?
Yeah.
F of x applied to 2 to get negative 1. Therefore, it must be the case that f inverse applied to negative 1 must return 2. Because if the function has the point 2 comma negative 1, the inverse function must have negative 1 comma 2. Better? Okay. 62. G inverse of 7. And for this one, we are given 3 functions. We'll see if we need all of them. But this time, we're not given a table. We are given a function, 3 functions. G of x equals 4x minus 1, and h of x, x squared plus x plus 2. We want to find G inverse of 7. Always think in terms of these bubbles. I think they really help. So I know that 7 must be here because I'm applying G inverse to it. I know there must be a number that I apply which function to get 7? Yes, I apply G to. So I have to apply G to a number to return 7. Because when I apply G inverse to 7, I have to get back that number. So the question is, which number, which x, makes G of x to equal? Exactly. So I have to solve this equation replacing G of x by,
7.
careful, G of x by, this is just a name. What name does this represent? It's right here. It's right here. I know it's late. I know it's late. Yes, G of x is a name. I cannot use it in anything. So I have to replace G of x by 4x minus 1 and get 7. I add 1, I get 8, so x must be 2. It's exactly the same process with this, but here it was easier because we were given the numbers. We didn't have to solve for anything. But it's the same idea. So let's do this, let's discuss this one more time. So we are given the function g of x, and we're asked to find how much is g prime of 7. G prime, sorry, that's the derivative. G inverse of 7, sorry. So I know that I have to apply g inverse to 7, and I have to get a certain number. But how do I determine this? It depends on the number that I apply g to get 7. And we got 2. Let's see if it works. 4 times 2 is 8. 8 minus 1 is 7. Indeed. So if G has the ordered pair 2, 7, G inverse must have the ordered pair 7, 2. How did we determine 2? We said, okay, what should x be so that G of this x is 7? So we have to solve this equation replacing G of x by its expression, because this is a name given to this expression. So then 4x minus 1 is 7. I solve the linear equation. I get x equals 2. So obviously G inverse of 7 then must be 2. Is this okay?
How is that different than replacing g of x with 7? So instead of plugging 4x minus 1 in for g of x and having, putting 7 on one side, why not just substitute 7 for g of x because they're equivalent? And then it'd be 7 equals 4x minus 1 in the original equation, and it's, I don't know, it just seems a lot less
steps along the way.
So how will you write it?
So the original equation, g of x equals 4x minus 1.
Mhm.
If you know that you're trying to get 7 because of
Mhm.
g.
Just dictate and I'll write it.
Yeah, 7 equals 4x minus 1.
And I wrote 4x minus 1 equals 7. So how are these two different?
That's what I'm asking, is why can't you just take the 7 from the g inverse 7 and just put it in g of x instead of sort of switching around the sides? Because switching around the sides is just an extra step that can create.
So you wanted to plug in, you don't have the inverse function. You don't have the inverse function of g.
No.
You have to determine the inverse function.
Yeah, but you know what g of x is. It's 7.
Okay, so, but how is this different from this?
Yeah.
You don't have g inverse. You want to calculate g inverse?
No, not.
But if you calculate g inverse, then you can plug in 7. That's another way. Actually, it's a very legitimate way. But 4x minus 1 equals 7 is the same with 7 equals 4x minus 1. So there is nothing different here. I wrote 4x minus 1 because I replaced this by 4x minus 1. Instead, you put 7 instead of this, which is the same thing. There is no difference.
Okay.
You still have to add 1 and divide by 4. However, if you had in mind to find g inverse, that's a very good idea. So quickly, I have g of x equals 4x minus 1, y equals 4x minus 1, x equals 4y minus 1. I add and subtract, so y equals x plus 1 over 4. So if I plug in 7 in here,
Yeah,
right, and then I get a divided by 4, which is 2. It's a very good method. It's a very good method, but it's a little bit longer. But you're making a very good point. But these two are not different. These two are identical. You replace this by 7, and I replace this by 4x minus 1. So these two equations are, if you look from the left or from the right, it doesn't matter. But very good point. So you could do this. And then you will get x equals 2. Any questions for me? Any questions? Okay, I'll do one more problem and I'll stop, promise. Last one, 64. And thank you for allowing me to catch up those 6 minutes. So f of g of age of 1. We are given those 3 functions. They're all here. Where do I start? Where do I start? From the innermost, so we have to find age of 1. So can anyone tell us age of 1?
4.
Do you all agree with age of 1 being 4? 1 squared plus 1 plus 2, 1 plus 1 plus 2. Very good. So now this is f of g of 4. Now can anyone give us g of 4? Here it is. G of 4. 4 times 4 minus 1. And the last one is f of 15. F of 15. 2 times 15. 30 minus 5. 25. Any questions?